We saw how we can find the limit of a function using the numerical approach. In this lesson, we will see how we can use the graphical method to find the limit of a function, or to see if the limit of a function exists or not. At the end of the lesson, you should be able to say which method is better, or if you should combine the two methods. So in the previous lesson, these are the main takeaways that you should have taken from the previous lesson. The first one is that the limit as x approaches a of f of x is equal to L if when x is equal to L if when x gets sufficiently close to a from both sides. Remember, it has to get close to a from both sides. F of x gets arbitrarily close to L. The second takeaway from the last class is that to find the limit numerically, you have to make x very, very close to a from both sides, always from both sides. And you have to see if f of x gets close to some value from both sides as well. And this important relationship was introduced in the last class, the limit as x approaches 0 of sine x over x equal 1. Very important relationship that will be useful in calculus. This is only when x is measured in radians, cannot be in degrees. X measured in radians. And so after we have studied limits, we would be able to find the instantaneous rate of change by just taking the limit as h approaches 0 of f of x plus h minus f of x divided by h. That's the limit as x approaches 0 of the average velocity or average rate of change. This is the same as average rate. So limit as h approaches 0 of average rate is instantaneous rate. Okay, how can we find limits using the graphical approach? Yes, in the previous lesson we saw that if you use the numerical approach to find the limit as x approaches 0 of x squared minus x plus 2, the limit as x approaches 2 of f of x, we saw that it was 4. What does that mean graphically? It means that when you take x going to 2 from the left side first, what is our f of x? This is our graph of y equal f of x. And when x is getting close to 2 from the left side, y will be getting close to 4, right? And when x is getting close to 2 from the right side, y will also be getting close to 4. Because from the left side and from the right side, y is approaching the same value, 4. It means that the limit of the function x approaches 2 of f of x is equal to 4. Because from the left side it approaches 4 and from the right side it approaches 4. Example, we have here a graph of y equal f of h. We need to find f of 0. Oh, it's just the value of the function when h is equal to 0. So this is our h equals 0. What is the function? The y value is negative 2, 3, 4. Negative 4. So f of 0 is negative 4. Now, what is the limit as h approaches 0 of f of h? You have to investigate from the left side and from the right side. From the left side, as h is approaching 0, y will be approaching negative 4. From the right side, when h is approaching 0, y will be approaching -4. So from the left side and from the right side, we get the same value. So it means that the limit as h approaches 0 of f of h is -4, because from the left side and from the right side you get the same value. Look at this other function defined in pieces. What you should note is that when you have a function like this, defined in pieces, when you have a filled out dot, a solid dot like that, it means the function exists at that point. It means the function at x equals 0 is that point. But when you have an open, this one is open, an open circle like that, it means the function does not exist at that point. So we need to look for f of 0. This is x equals 0. F of 0, the value of the function at 0 is 4, not -3. F of 0 is 4, not -3. How about the limit as x approaches 0 of f of x? You have to check from the left side and from the right side. From the left side, as x is approaching 0, f of x is approaching 4. And from the right side, as x is approaching 0 from the right side, f of x is approaching -3. From the left side and from the right side, the values that f of x approaches are not the same. So the limit as x approaches 0 of f of x cannot exist. Should it be -3 or 4? It cannot exist because it approaches two different values from the left side and from the right side. So this one does not exist. We can write it as DNE, does not exist. Does not exist. Okay, let's investigate the limit as x approaches 0 of sine pi over x. And then we will do it using two methods, the graphical method and the numerical method. Let's start with the numerical method. Let's have our x values and our f sub x values like that. Let's have our 0 there. And then from the left side, as x is approaching 0, let's do -0.1, -0.01, -0.001. Make x very close to 0. From the right side, let's do the same. 0.1, 0.01, 0.001. What is f of x? When x is -0.1, sine pi over x becomes sine pi over -0.1, which is sine of 10 pi, -10 pi, which is negative sine of 10 pi. we know that sine of pi is 0, sine of 2 pi is 0, sine of 3 pi is 0, sine of 4 pi, sine of n pi is equal to 0 when n is n equal 1, 2, 3, and so on. So this will be equal to 0. So this will be 0. This will be sine of negative sine of 100 pi, which is 0. This will also be 0. This will be 0, 0, and 0. Now, the question is this limit therefore equal to 0? That's a question mark. To confirm whether it is 0 or not, we need to use a graph. I can draw the graph of sine of pi over x. We see that our graph near x equals 0 is oscillating. Let me use a better calculator for that. Yes. Near x equals 0, the graph is changing very quickly. Let me use an even better calculator. Here it is. The graph is oscillating near x equals 0, and it doesn't approach a fixed number. You see, it's very close to each other. The lines are very close to each other, and they oscillate. They are almost thick. It's jumping between -1 and 1. So it means that that limit cannot exist, because from the left side and from the right side, you see they are not getting to the same value. So this limit is not equal to 0. Actually, this limit does not exist. So now you see how you can use the graph to check if a limit exists or does not exist. Please download the worksheet that is below this video and solve exercise 1 to 22 and submit on Edmodo. Thank you.